Hello and welcome to Dr. Taylor's Pedagogical Notes. We are going to look at a mixed number divided by a fraction. I have a little bit of convolution with that division. You know, we looked at that with the fractions, but we're going to dig in and get through it anyway. All right, so again, we're going to go from concrete to abstract, and there's my links for resources for teachers and students. Let's get right into it. Got a Geoboard, and the strategy is going to be basically the same as before, so I'm going to jump right to graphical. Because the Geoboard was just a little bit tough. If you remember when we looked at the fractions where you were cutting something in half, if the Geoboard wasn't divided in an easy to divide number, then you had nickels getting cut in half, and it starts to become deceptive about what you're counting. The graphical one is just a little bit easier, and so I might use something besides the Geoboard. If I want to do concrete, I'd probably use colored squares and orient them in some contrived way. But let's go ahead and jump right to the area model, okay? So we're going to look at the area model. We've got 4 2/3 divided by 3/5. If you remember when we said if we divide by something smaller than 1, our quotient, or the answer to our division problem, is going to be bigger, right, than the dividend. So I expect an answer to be more than 4 2/3, because if I divided it 4 2/3 by 1, it would be itself, right? If I divided it by 2, it would be half of that. It would be 2 1/3. So if I divide it by 1/2, it's like multiplying it by 2. If I divide it by 1/5, it's like multiplying it by 5. Well, I'm dividing it by 3/5. That's just crazy. I can't think about it. So what I'm going to do is I'm going to figure it out and then see if I can figure a way to manipulate that with a mental trick that would help me get those answers without all this work. And that's okay. The work is what gives us the mental trick understanding. All right? So I'm going to begin by decomposing the 4 2/3, which means I'm going to break it into easy, friendly numbers, friendliest being 4 and the 2/3 part as a separate. Okay? So the whole number part and the fractional part. And I'm going to do the division for each. Okay? So later we will recompose those two divisions and get our final answer. Recompose just means to put them back together. All right, let's begin by drawing two parts of the decomposed mixed number. So the whole parts are 4, and the divisor is n over 5. In this case, it's 3/5, right? But we know we're going to try to take that 3/5 down to a unit fifth, 1/5, and then multiply that by 5 to get a 1 to something comparison to say that one partition has this much in it based on that first fraction. So that was a little bit, synopsis from the division of fractions, and you can check that out if you think you need to. But stick it out here and see first. All right, so there's 4 parts. You can see that 1, 2, 3, 4. That's just arbitrarily. It didn't have to be 4 squares, just 4 holes, okay? And this is fifths. So it's the shape of 1 cut into 5s. Can you see that? So the area of 1 needs to be the area of 5/5. If you don't use that same area, then you've lost all the value of an area model. If I'm just drawing arbitrary shapes, then those shapes are meaningless, okay? This is worth 1, and so is that. That's why they're the same size. Now this is cut into 5 pieces so that I can look at however many fifths I want, in this case, 3 of them, okay? All right. So there's my 3 now, which means I'm going to hatch 3 of those fifths. Now that's not just 5/5, that's 3/5. Can you see it? I've eaten 3/5 of the pizza and 2/5 remain, however you want to look at it, all right? So now let's take a look at what we would do with that. Now the 4, this 4, correlates to the 3/5, okay? But we cannot use this relationship very easily. So what we want to do is we want to look at how this can become 1/5. What would I have to do to make 3/5 become 1/5? That's important. That's what we're trying to get. We're trying to get this fraction to become a unit of its denominator. And that would be simply to divide, right? How many pieces were there? 3. I won only 1. So what did I divide 3 by to get 1? 3. I divided it by 3, right? If I divide that by 3 to get 1/5, what am I going to have to do to the other side? I'm going to have to divide it by 3, okay? So there's my 3rd. See? So now, if this correlated to that, come on, this is really frustrating. If this correlated to that, then one of those correlates to one of those. Can you see how that works? Hopefully. So this pink shape correlates to that. So this was 4 whole pieces, right? So this became 1, 2, 3 thirds, 4, 5, 6 thirds, 7, 8, 9 thirds, 10, 11, 12 thirds. So 3/5 correlated to 12 thirds. So 1/5 correlates to 1, 2, 3, 4 thirds. Can you see it? That's the partition equivalence we try to generate. Get us down to a unit fraction corresponds to a unit fraction. Okay? So finally we can compose a direct relationship through the repeated addition on the left. Okay? 1/3 and 1/3 and 1/3 and 1/3, which I just basically said before it unfolded, is 4 thirds. Okay? So 4 thirds correlates to 1/5. There's my ratio. And I'm sorry for the numbers. It really, on Google, it's hard to make fractions. So Google Slides don't always cooperate. And they certainly don't want any part of an improper fraction. So anyway, now I need to turn that into a 1. I don't care. That will become what it is. The thing I made a unit fraction is what I'm going to create a unit out of, because that's the easy one to work with. That's why I'm using it. So how many fifths does it take to make a whole? And the answer is 5, right? And so since I have one of them, I would need 1, 2, 3, 4. You see, it's on the thing, even if you don't think it. Intellectually, you can't think of it. You can see it's on there. There's 5 of those things, right? So what that means is I have to multiply through repeated addition that to become a 1 5 times. What I do to one side, I have to do to the other side. So I'm going to multiply this, right? 4 thirds, not 1/3. 4 thirds is that piece times 5. That would be 4 thirds and 4 thirds and 4 thirds, right? Or 5 times 4 thirds, which is 4, 8, 12, 16, 20 thirds through repeated addition. And now I know that one partition correlates to 20 thirds fraction. Is that more or less than 1? That's definitely more, right? And 3 goes into 20 a bunch of times. I could use division through algorithm, or I could use repeated subtraction, right? I could say, well, 20, take away 3 is 17, take away 3 is... So let's do something. Let's do that. So let's take a look at what that becomes as a mixed number, okay? So now the 2 thirds part. So we got the 20 thirds, and that correlated to the 4, right? So I now need to correlate to the 2 thirds part. All right, now remember, if this is 2 thirds, then I need to shade in 2 of the regions. But remember what I did here? I had 3/5, and I cut it into 3 pieces to get 1/5. So I've got to cut this, again, the same way I did the last model, into 3 pieces. And now I'm looking at just the bottom piece and just the bottom piece here, right? So we see that this was 1, 2, 3, 4, 5, 6 ninths. So now I have 1, 2 thirds. Can you see it? The bottom is 2 thirds. So 1/5 correlates to 2 thirds. That's what we've got here. Or not 2 thirds. So there's 1, 2, right? Out of 9. Okay? But I only want 1, right? So I need 1, 2, 3, 4, 5 of these. Therefore, I need 5. Remember, I didn't count that one. I didn't have 3 ninths. I didn't have the full third, which I was saying at first, because I only had 2 of those pieces. So even though I cut it into pieces that made 9 of them, I'm looking only at one piece, the bottom or the top, the middle, it doesn't matter. I'm looking only at one partition, and that's 2 of the possible 9 that were there. Okay? So now I have to get a 1 out of the 1/5, right? So I need to multiply that by 5, or do 5 of them, which means I need 5 2 ninths, or 2, 4, 6, 8, 10 ninths, right? So now I can say 10/9 correlates to 1. So now I had two correlations to 1. One of them addressed the fractional part. This much of the fractional part goes into one container. The other one was this much of the whole number 4 part went into one container. So I need to put those two together. I need to look at the 10/9 and the 20/3 because each of those, remember this was 4 and 2/3, so now this is 20/3 and 10/9. I'm putting them back together, recomposing or recombining those. Now, to do that, I don't have a common denominator, right? And so that might make it a little tricky, but we're going to go ahead and look at it. 20/3 and 10/9. Let's do this to use another strategy for division, which is what a fraction actually is, an unsimplified division problem. Okay? So strategy is repeated subtraction. So what I'm going to do is I'm going to do 20 minus 3, and I'm only doing this to give you another strategy. I could have done another thing, but this is the rudimentary strategies from basic pedagogy. So 20 minus 3, right? And I keep subtracting 3 until I'm down to 2 is not, right? 2 is not 3. So I have 1, 2, 3, 4, 5, 6 3s, right? But I got a 2 left over. So what that is how many of them? That's 6. And the leftover part is 2/3. Okay? So that's what 20/3 is. It's 6 2/3. All right? And now we're going to do the other thing for 10/9. So let's do 10/9. 10 minus, so basically this minus that, right? This minus the 9. Oh, it only happens once, and I'm done. It goes in once with a remainder of 1. So that is going to be 1 1/9. Now I need to add them. Well, it's easy to add 6 and 1. This is why I did this, to make these fractions smaller, to take all the big whole parts out of the improper fraction. So what's 6 and 1? It is 7. So I have 7 whole parts, but I still need to do the fractional part, which is 2/3 and 1/9, right? So I'm going to do that next by saying, oh, well, here's thirds and here's ninths, right? I'm adding now. So it's an easy thing. Remember, I'm going to transfer partitions. I'm going to shade based on the numerator. There's 2. And then this one, there's 1, right? Let's transfer the partitions. Getting a common denominator is what that really means. How many, this is 3 by 9, isn't it? How many total squares are in either of those pizzas? 3 by 9. That's the denominator. What's the numerator? How many pieces I ate? Well, I ate 2 by 9, which is 18, 19, 20, 21. So what did I do? I ate 21 pieces out of 27. Right? See it? So there's my 3 by 9. There's my 21. So I get 21 out of 27. My numerator. Okay. So I'm done, right? Whew, thank God. But wait a second. Look at that, 21 and 27. There's a little trick. If you add the digits up and they add up the number you can divide by 3, the whole number is divisible by 3. What's 2 plus 1? Can I divide 3 by itself? Yes. What's 2 plus 7? 9. Can I divide 9 by 3? Yes. So I'm going to divide the top and bottom by 3, that common factor again, right? So I'm going to do that, right? And I'm not sure what happened here. Oh, here it is. I'm doing repeated subtraction. 3, 3, 3, 3, 3, 3. So how many times does a 3 come out? 1, 2, 3, 4, 5, 6, 7. That's the 21. 7. How many times does 3 come out here? 1, 2, 3, 4, 5, 6, and keep going. So what is it going to be? That's not what I wanted. So we see that the 3 came out of 21 a total of 7 times. That's my new numerator. And we see that 3 came out of this. You figure it out. You would pause now and do it. Okay, welcome back. 9 times, which is your new denominator. And again, just like we talked about, when I divide by a number less than 1, my answer, the quotient, is going to be bigger than the dividend, the number I originally divided. There's an inverse relationship. Okay? And there's my final answer. And I thank you. Oh, I'm sorry, abstract. My bad. Mental math. I might mentally model it. I might ignore the 4/3. I might imagine partitions. I might finally get an n-to-1 relationship. I might convert that to 4.66 and to convert that to whatever its decimal is. Could I do that and then try to figure out the fraction that's left over? It's not always as easy, but I can. So there's a lot of ways I can do it. 3/5, 4 divided by 3/5 is like 4 times 5/3. You know, and so there we are. You know, we end up with our 7/9 to doing that 5/3 times 4 and 5/3 times 2/3. That's the invert and multiply algorithm as it unfolds. That's how your mental math generally goes for division of fractions. Doing the partitions in your head is crazy wild. You're going to keep, change, flip. You're going to invert and multiply. That's what's going to happen. But you need to understand how come. That's what this is about. So there we are. Thank you very much. And I'll see you on the next and final presentation, at least for now, which is estimating the square root of a whole number.